Thank you so much for having us. We appreciate all of the wisdom that's here on the line with us.
Yeah, well, thank you. Yeah, thank you for that, Dr. Bush. And we do appreciate you coming on. You know, I have clients from all over the world who are very, very sick and challenged. And oftentimes, one of them says, hey, check out this product, right? I found it, I've been using it, and it seems to be helping. But that's how I came upon this product some many months ago. But you know, I always do. I always listen. I go and I start researching different products, and you know, I saw some things that I read right off the bat that caught my eye. You know, one thing that I was very interested in is, of course, you know, we have experimented with every probiotic and every bacteria, you know, and it's very limiting is how much you can get a gut well with that. And so immediately I was thinking this was going to be just another probiotic type of product, and I saw that it wasn't. It was based more on redox molecules, which I know a little bit about, and you know, and what it did for the tight junctions, which is this is a big deal today. You know, I always say 95% of Americans have a leaky gut and just don't know it. Most of them.
Yes.
Yeah, and of course today I'd love to talk about, you know, some of these chemicals that we are being exposed to today like no other time in history that are leading to this massive leaky gut epidemic. And but I also want you to tell the story that I got to hear at one point from you directly about how this product came to be, because it came through, oddly enough, if I'm wrong, cancer research, right? I mean, that's kind of what, yeah.
And so I was going down very narrow pathways of belief system, narrow pathways of science, very much in my chemotherapy, cancer kind of mindset. And I was at the University of Virginia from 2002 to 2010, and at University of Colorado before that. My research had matured from the endocrine world into the cancer world, and I was kind of working on tumors of the endocrine systems. And I had stumbled upon a pathway that was using vitamin A compounds to kill tumors. And the way that it was doing that is through apoptosis, or programmed cell suicide. And that's an area that actually is very apropos for an endocrinologist to study, because we are a field that studies endocrinology and metabolism is the name of our subspecialty. Metabolism, in a nutshell, is the science of the mitochondria. The mitochondria are what burn energy and produce energy in our bodies. And so that they really set the metabolic rate. And so when you look at cancer from an endocrinologist standpoint, it's much different than an oncologist standpoint. An oncologist is kind of just trained to think, kill the cell with a toxin. An endocrinologist, starting to think about it from a metabolic standpoint, stop seeing the cancer cell as something that needs to be killed and start seeing the cell, or the cancer cell, as the weakest cell in the body. And that's a really interesting thing, is cancer cells are the most injured, damaged, and unrepairable cells in the body. And yet we've built this massive $3 trillion fear machine around these cells. And it's interesting, of course, we could have another podcast on the word fear. I mean, that emotion tied with a disease is so powerful in changing our perception as doctors, changing our perception as patients, and everything else. And I was definitely locked into that fear pathway, thinking, oh my God, I got to kill these cancer cells, turn on the suicide, get them gone. But as you start working in metabolism, you start to realize, wow, these mitochondria, which are non-human, are taking care of the human cell in which they live. Mitochondria is basically a prokaryotic cell. Prokaryotes, like bacteria, mitochondria, these guys are their own little life form. They have their own DNA. They replicate separate from. So that was my world. Okay, mitochondria, and when the mitochondria eat food that you eat, the food that's on your plate is inaccessible to the human cell. It can't use any of the fuel there. And so the bacteria have to liberate that, and then the liver has to turn it into just two things, fat and sugar.
Sure.
Fat and sugar are the only things that are going to ultimately fuel a cell. And actually the human cell can't use either of those. And so the mitochondria have to then consume the fat and sugar, turn that into electrons, and then take those electrons, pump it through the electron transport chain in the mitochondria, and produce ATP. And ATP is ultimately the fuel that runs the human cell. So how many times are you separated from the food on your plate? It's pretty interesting. And so when somebody's eating food and not feeling well, my whole world started to change when I started learning nutrition. It's like the kale can't be feeding the patient. It just can't. It has to be feeding the bacteria, feeding the mitochondria that are feeding the human. And when you start to see that relationship, the paradigm shift that happened to us in 2012 starts to really be set up. And so my cancer research died pretty quickly when the NIH pulled funding at the University of Virginia. This was 2009, 2010. We were in the middle of a massive recession, as you recall. Everybody was losing their houses. NIH funding was crashing. And so our department went from 75 faculty to 23 faculty in the course of a year or two. And so we just had this devastating effect on academia. My research was just funding dried up in the midst of that. And so I had to leave the university at that standpoint. And at that point, I was pretty depressed because I really loved research. I loved the microscope. I loved teaching. I was a chief resident before I became faculty. I loved teaching. And I thought I was going to be just, isolated out in the community and not be able to really do any of my passions again. So I started this little clinic down in Scottsville, town of 550 people out in rural Virginia, and they are in a food desert down there. There's not a significant grocery store in the entire county, so they eat from Sheetz gas stations and the like. And so I moved down there to try to just teach people how to eat and reverse their diabetes and other things. And so in that midst, I was 2 years into teaching people how to eat nutrition, and we were starting to see clear evidence that healthy food was not translating into health in the patient. It wasn't working. And so no matter how much I juiced them, no matter how much kale I gave them, the cancers weren't going away, the diabetes wasn't going away, they were stuck. Now 60% seemed to just bounce back and do pretty good. But there was a stuck population, and even the ones that bounced back never bounced back all the way. They just got better, but not well.
Yeah.
And so I had people plateaued, and I had people that just weren't responding. And that started just asking a lot of root cause questions. What's the root cause of disease? And this had actually come to me at the University of Virginia when I was studying cancer under the microscope and treating diabetes in the clinic. When I was actually cleaning out the ankle, a big ulcer in the ankle of a diabetic patient in clinic, and I had just minutes before been in my lab looking at cancer cells under the microscope. And it suddenly dawned that those dead and dying cells in this guy's ankle were the same as my cancer cells that were on the verge of dying all the time. And that was the moment where everything started to click for me of like, wait a second, there's not cancer and diabetes. There's only one thing. It's ultimately just a failure of the cells to repair. And that is caused by inflammation. And so inflammation started to be seen by my brain as like, oh, one thing. Not 35,000 diseases with 100,000 different treatments. One disease with one potential treatment. And so when that shift is big, right? And I think you've been through that. I think every practitioner out there that's now practicing a more integrative type of practice has come to some version of that conclusion of, okay, it's simpler than we were taught. We don't need all the pharmacy. We don't need all this. We got to keep it simple. And so we started asking root cause questions then of what's the root cause of inflammation? And when you start asking what the root cause of inflammation is, if inflammation is the root cause of all disease, and you look across that population that we have, autism has gone from 1 in 1,000 to 1 in 40 over the last 50 years. Yeah. We've got major depression, 1 in 100 to 1 in 2. Massive, massive sea changes in these chronic diseases. And so if inflammation is the root of all of those diseases and they're all increasing at the same time, it starts to say there's something that happened in our environment that changed. And because I was feeding kale, I just thought, well, maybe the kale has changed. Because I was reading research from the 60s and 70s that really set us in motion in nutrition to say that plant-based diets could heal just about anything. And they had amazing science. But we weren't seeing that replicated. And so was there something wrong with the kale? We started going down that avenue, started pulling articles on nutrient content of food. And you only need to pull 3 articles to see the devastation. The lycopene that we had in tomatoes in 1950 were completely different than what we have on the shelf today. The food that is on the shelf looks pretty, but its nutrient content is completely devoid. Do we blame the tomato plant for that? No, we blame the soil. And so that's how we finally got a Western medicine doctor from a pharmaceutical approach to chemotherapy to start thinking that, wait, something's in the soil, and something in the soil could potentially help. And so with that shift, I was talking about soil, and my colleague in clinic, who's not a scientist by training in the academia, but is a self-trained scientist through working in integrative health clinics for almost 40 years. He's a genius. And he pulls this 90-page white paper on soil science and brings it into my clinic. And I start flipping through this thing really quickly because I'm in a busy clinic and behind. And I flip a page, and sitting in the middle of that page is a carbon molecule that has these binding sites on the end of it that look for all the world the chemotherapy that I'd been making. And that stopped me in my tracks. I said, my first split second was somebody spilled chemotherapy in the soil. And then my second thought was, wait a second, I already proved that vitamin A from a carrot can kill cancer. What if the carrot didn't make it? What if the carrot got it from the soil? And that was such an easy closing of the loop. And it took us only a couple more weeks of research to find out that that molecule that was sitting in soil was made by a bacteria.
Yeah, of course.
That was a massive breakthrough for my brain, because the mitochondria I had mentioned to you are making these little metabolites. I don't think I told you, but they make redox molecules that you had mentioned in the process of making that ATP. And so ubiquinone and all these enzymes in the electron transport chain, every time they move the electron past to get it to the ATP production, they make a redox molecule.
Right.
And these are small oxygen-hydrogen binding relationship molecules, and they can only bind once because they're kind of like a bumblebee. They can bind once and then they're done. They can sting once. What was sitting in the soil was a carbon backbone molecule with 17 different potential binding sites around it. With the understanding of molecular structure, you can see, oh my gosh, if you bind oxygen and hydrogen over here, the molecule isn't done. It's got lots more activity. And so the concept of a stable, renewable redox molecule has never been introduced to the literature. And so this is the breakthrough that we had in 2012 is, oh my gosh, there's such a thing as a stable redox molecule, and it's made by the bacteria. Let me close the loop for you now. Mitochondria and their redox molecules are the communication network of cell repair inside the cell. And I had studied that. Thousands and thousands of labs around the world have studied those redox molecules into oblivion, and it's clear that at least 50% of the aging process is a loss of redox molecules.
Right.
And so with that knowledge that they are the communication network of youth and healing, and a loss of them causes a lack of cell repair and aging, you're 90% of the way there. Now think about the body of what we know from the last 10 years that bacteria are important. And now I just told you we've just found a molecule in soil that is made by bacteria that has redox potential. Let's think about where mitochondria exist for a second. Mitochondria only are inside of eukaryotic cells, multicellular organisms. So the human, the animal, and the worm, all those have mitochondria. And that's how they do cell communication. But we have 30,000 or 100,000 species of bacteria that don't have mitochondria in them. They're prokaryotes.
Mm-hmm.
How in the world would they do cell-cell communication without a mitochondria? They can't, and so they have to make their own redox system. And so that was our breakthrough is, oh my gosh, the bacteria are making their own system. They can communicate. And that answered many, many questions very quickly as to why UCLA and UCSD were publishing these papers at the time. This was 2008 to 2012. They put out a bunch of papers that said, if you have these bacteria in your gut, you get breast cancer. If you have these bacteria, you get colon cancer. If you're missing these bacteria, you have major depression.
Right.
And so they were drawing this link between disease and the ecosystem of the gut, but nobody could figure out how they were connected.
Yeah. Yeah. Go ahead. Yeah, I mean, one of the problems right there is that, you know, when I read that research and when we started reading that research some years ago, we started saying, okay, let's put these bacteria there. It didn't work. You know, I mean, the probiotic, you know, we give people probiotics, oh, yeah, a little bit better, this is a little bit better, but we're not solving these big problems like we thought when we first started discovering the relationship between bacteria and certain conditions.